Now we shall be looking into the dimensional analysis on the SI unit of the magnetic field. Now, as we have seen that the magnitude of B, or say the magnitude of the Lorentz magnetic force, was F equals to B Q V sine theta, or we can write as this magnetic field, the magnitude of the magnetic field now as equals to F divided by Q V sine theta. Now, as we know that the dimensional analysis for force is basically M L T to the power minus 2. Why? Because force, the SI unit of force is Newton, and we could say that force is equals to mass multiplied by acceleration. Right? So this M stands for mass, and acceleration means the SI unit of acceleration is meter per second square. This meter is for length per second square. It means that second to the power minus 2 or time to the power minus 2. So we can write as, over here the numerator is of only F, so we will write it as M L T to the power minus 2. And now for Q, what basically Q is? We know that I is equals to Q divided by T, or the rate of change of this charge with respect to time, or we can say that Q is equals to IT, right? And the dimensional analysis of I is denoted as ampere, and this A stands for the ampere or the dimensional analysis of I, and T, this is multiplied, so this will be simply T. So the dimensional analysis of Q or the charge will be AT. So we can write it as AT, right? And over here we know that this V, this is the velocity or the drift velocity. So we can write over here that V is equal to, the dimensional analysis of V is simply L T to the power minus 1. As we know that the SI unit of this velocity is meter per second, where meter this is length and per second when second to the power minus 1. This is time to the power minus 1. So we can replace this V, the dimensional analysis of V, as L T to the power minus 1. And sine theta, the sine theta is basically a dimensionless quantity, right? So over here we could see that this will be equals to mass. Can we cancel out on the denominator? On the numerator this is mass. Can we cancel it out? No, simply we cannot. There is no other mass. So M will be over here. Now this L, length. Is there any other length? Over here we could find this length. So the numerator L and the denominator L will cancel out, leaving no L. We have done of M and L as well, because this two will cancel out, right? Now T to the power minus 2. T to the power minus 2, it means we can write here likewise that T to the power 2 on the denominator side. Now on the denominator side, see, there is A. We can write this A. There is again a T. We can write this T once again. and t to the power minus 1, it means that this will be transferred now to the numerator side as only t to the power plus 1 or t, right? So we can see that this t will cancel out this, leaving only t as the numerator, as the t in the denominator, and this t multiplied by t, right? So this will come out to be m, and on the lower side we can write it a t, this is square, likewise. So we can write the dimensional analysis as m multiplied by a to the power minus 1 and this t to the power minus 2. So this is the dimensional analysis of this B, and the SI unit of B is as per this dimensional analysis, and it is Tesla. Or in SI unit we could say it as m for kg or for kilogram multiplied by, or this will be per, because this are on the denominator side, we can write this is for ampere, and this is time, means second to the second square, right? This kg per ampere second square is known as Tesla, and this Tesla, the unit, SI unit of this B, Tesla, is given in respect to the famous scientist Nikola Tesla, right? Thank you.